Well, hello. We're going to do some review for the distance learning final test. I'm not going to do all the questions that might show up on the practice, but I'm going to do enough because you don't want to listen to my voice the whole time. You're probably going to fast forward. First, remember if we have something like this, is this a growth or decay? You always want to look at this number right here. So since this is less than 1, this would be a decay. If that number was greater than 1, it would be growth. So that's reviewing how do we know if it represents exponential growth or exponential decay. What if I had a question that said something like, I have 200 people and we have a growth of 2%. What would it be like in 10 years? How would we set that up? Well, that's going to be this equation right here. Actually, I think I did that. Beep, burp, burp. This. 1 plus or minus RT. So in this case, whatever you start with is your P. So we would have 200. And then it's a growth, so it's a 1 plus my rate. 2% is the same thing as 0.02. So I'd have 0.02. I'm asking over 10 years, so that would be my time. I would type this exact same thing to my calculator, and I would probably have to round to the nearest number, 244 people. Or if I was just asking for the equation, it would be this. Bing! Now, what if I want to write something as a log? So we know that 81 is equal to 9 squared. Remember your base here, exponential base is the same as log base. So this would be log base 9, and these two numbers flip-flop. So this becomes 81, and whatever the exponential was becomes what it is equal to. So that's how I would rewrite it as a log. What if I want to evaluate something if I had like log base 2 of 64? Well, you could rewrite this. This is the same thing as 2 raised to what power is equal to 64 if you know that off the top of your head. Or you can type this right into your calculator and you would get 6 out. Remember, if you don't have that, you can email me so I can show you. But there is a video that I showed you how to do a change of base if you don't have that special function on your calculator. Reviewing some log properties. So let's say if I have log base 3 of 4 plus log base 3 of x, how do I write this as one single log? Well, because it's adding right here, whoopsies, adding, log base 3 doesn't change, and this becomes 4x. If it's adding, you multiply. If I had something like log base 5 of 10 minus log base 5 of 2. You hear my kids yelling? Oh, the joys of distance learning. Subtraction is going to be the same thing as division. So the log base 5 doesn't change. Whatever is positive goes on top. Subtraction goes on bottom. You have to simplify that. So log base 5, 10 divided by 2 is 5. And actually, if you type that into your calculator, you would get just 1. You want to see if you can simplify. If I type that in my calculator and I get a whole bunch of decimals, I would leave it as log base 5 of 5. In this case, it simplifies to 1. So reviewing some solving problems. So let's say if I had 4 raised to the x is equal to 64. I can rewrite this as a log. So my base here is 4. So I could go log base 4 of 16 is equal to x. Sorry, I meant to say 64. 64 here. That should be right there. If I type that in my calculator, I would get 3 out. So that's one solving problem. What if I had something like this? 5 to the 2x is equal to 12. So I can still rewrite this as a log. My base here is 5. Log base 5 of 12 is equal to 2x. This is multiplying, so opposite of multiplying would be dividing. I'm going to divide by 2. Make sure that this is the only thing you're taking the log of, and then divide by 2. The answer would be 0.772. 2. You should be checking to see if you can type that in the calculator and get what I get out. Let's review some factoring, shall we? What if we had something like this? 121, let's try. So in this case, there's no middle number, so that would be like if there was a 0 right here. So you're looking for two numbers that multiply to get 121, add together to get 0. So those two numbers would be x plus 11 and x minus 11. This is kind of a special case because 121 is a perfect square. What if we have a number in front of the x for review factoring? So you want to find the factors of my first, factors of your last. Look at how it's negative, so one of these has to be negative. This is where you just guess and check. The only options we have here are 3x and x, so that's why I'm going to split that up. I'm going to put this minus 1 here and this plus 2 over here. So this is me guessing. If I'm going to check this, this would be 6x minus 1x, and that gives me a total of 5x. This right here is not 5x, so I'm going to try again. Here's me guessing. This time I'm going to put the plus 2 over here and the minus 1 over here. And check my outside, I get a negative 3. Check my inside, I get a negative 1x. That's perfect, so this would be my final answer. And last two review questions are going to be when I multiply and divide with polynomials in 8.4. So first I have to factor both of these, factor the top and factor the bottom. So just like how I just reviewed factoring, that's what you should be doing. So I'm not going to go over that process because you can do guess and check. So rewind if you want to review factoring. So here I have it all factored. Now I can simplify. So remember multiplying, that can just go straight across. So anything that's the exact same on the top and bottom can cancel it out. So this whole thing, the 3x plus 4 with this 3x plus 4 can cancel. This 3x minus 4 with this 3x minus 4 can cancel. This x plus 5 and this x plus 5 can cancel. These cannot cancel. There's an addition and there's a subtraction right here. So my final answer would be x plus 4 over x minus 4. Remember, you have to factor and cancel on top and bottom. And last, division. So when I'm dividing by a fraction is the same thing as multiplying by the reciprocal. So when I multiply by the reciprocal, I'm change this multiplication and I flip the whole thing. So everything that's on bottom now is on top. Everything that's on top is now on bottom. However, you have to get rid of these negative exponents. The negative exponent is just with the x and y, not with this 3 and 16. So this first fraction does not change whatsoever. The 3 and the 16 are still right there, but the y comes on top to become positive, and the x goes on bottom, become positive. Now you can multiply across and then simplify, or else I'm going to simplify this 3 and this 6 can be simplified to be 1 and 2. 3 over 6 is the same thing as 1/2. Same thing with this 4 and this 16. So this becomes a 1 and this becomes a 4 because both of those are divisible by 4. Now I can look at my x and y's. So if I multiply across, this 1 plus times 1 is 1. This 2 times this 4 is 8. If I look at my x's right here, looks like a peanut. There's more x's on bottom, so it would be x to the 4th, and then subtract x to the 3rd, that's just 1x. If I look at my y's, nope, I'm going to try to pick a different color. Right here, my y's right there. There's 2 y's on top, 4 y's on bottom, so y's are going to remain on bottom. And again, subtract. So that right there is my final answer. And that right there is review for your final test on distance learning.